Good morning, everyone. Actually, my work is on a topic an analysis of the phrase-based SMT for English to Manipuri language. So today I'll be presenting one of our co-work, that is Professor Bikul Syam Purkase. He isn't available today. So first of all, machine translation. It is an application area of natural language processing, which deals with the process of translating from one natural language to another. So we all know that there are many approaches to machine translation or many techniques to machine translation. And out of those, the most recent, that is NMT, and the other SMT, that is statistical machine translation and neural machine translation, are the most prominent ones. Both these two approaches, that is SMT and NMT, are corpus-based approaches. So SMT was the most dominant approach for more than a decade. Until recently, NMT emerges as the state-of-art approach. So even though there are the large-scale MT engines such as Google Translate, Amazon Translate, okay, they were earlier based on SMT, but however, with the coming of NMT, they all have been shifted to NMT paradigm. So as we all know, NMT, no doubt it provides good performance for language pairs which have high resources. But for language pairs that are under the low resource category, NMT does not provide good performance. Okay, so there are works that claims that SMT provide good results for low resource category. So our work will be based on the phrase-based SMT technique, which is the most commonly used technique or the prominent technique out of all the SMT variants. So our language pair under consideration is from English to Manipuri translation. And this language pair comes under the low resource category. And these two languages have disparate morphology. So Manipuri is a language that is spoken in the state of Manipur. And it has two scripts. One is the Bengali script and another is the Meitei Meg script. So our work will be based on the Bengali script. So as I've mentioned now, English and Manipuri are two languages which has got notable linguistic differences between them, which poses challenges during implementation of a machine translation. So the difference starts from the genesis. Manipuri language belongs to the Sino-Tibetan family. It has got subject, object, verb structure. It is tonal, got richer morphology. It has aspect predominance, and it belongs to syntactic category, and it is agglutinating in nature. While English comes under the Indo-European family, it has got subject, verb, object structure. It is stressed and non-tonal language, poor morphology, tense dominant, and analytic category. So apart from this, the unavailability of pre-processing tools and resources in the open domain for Manipuri languages further amplifies the challenges of machine translation. So for our work, we have used the corpus from domains of tourism, agriculture, and entertainment, and we'll be evaluating them by using the blue metric. So the aim of our analysis. So it is all known that SMT is a long dominant approach in the field of machine translation, but with NMT has taken over SMT in most of the major languages. But for low language resources such as English to Manipuri, which has got disparate morphology between them, it cannot be assumed unless we experiment which of these two techniques will be more practical and more suitable. So our work will be a preliminary and exploratory work towards understanding the feasibility and the potential of a phrase-based SMT under low resource conditions. So we train and test our systems on different domains with different training sizes and compare their blue results. So there are many MT engines, large-scale MT engines available in open domain. For example, like Google Translate, Amazon.Translate, Yandex.Translate, which easily implements translations for languages which has got high or huge resources. However, the problem is with low resource languages. So whenever you have low resource languages, even the big empty engines such as Google Translate or whatever, they even find it difficult and challenging to implement the translation tasks. So for Indian languages also, apart from the support provided by these big empty engines, there are systems such as Anuvadak and Anglabharti, which are based on major Indian languages of India, such as Hindi, Bengali. Okay, but as we all know, India is a country with diversity of languages spoken all over the country. So for languages such as Hindi, Bengali, they have dedicated NLP toolkits available for such languages. However, for remaining of the languages which are not widely spoken all over the country, machine translation for those languages are lagging behind. For example, like the northeast section of India has got a diversity of languages with multiple dialects. Some of the languages are Mizo, Boro, Kokboro, Manipuri, Assamese, and so on. For these languages, very little to no work has been done on these languages. So Manipuri languages, it is a language which has been recognized by the Indian Union as one of the scheduled languages. But however, developments or applications related to NLP are far, far behind. So one of the biggest factor to this lagging behind in the field of NLP is the unavailability of resources and NLP tools. And even if it is there, it is not available in the open domain. So recently, Google Translate has provided support for Manipuri language. However, it claims that it has used only the technique of zero shot translation. That is, it has used only the monolingual text of the Manipuri. So it haven't used any parallel corpora. So apart from this, some of the early works on machine translation with regards to Manipuri language are found in the work of Manipuri to English example-based machine translation, Manipuri to English bidirectional SMT systems, factored SMT for English to Manipuri using suffix and dependency relation as factors, and phrase-based SMT using reduplicated multi-word expression. These are some of the early works that has been done on MT. Recent works on Manipuri by using NMT are also found, such as unsupervised neural machine translation for English and Manipuri, statistical and neural machine translation system of English to Manipuri, a preliminary study. So both these systems, system that uses NMT, they have claimed that their NMT systems have scored better blue than the Fresnel NMT. So in another work, we have found where they compare an SMT and NMT system by incorporating morphological analysis in both of the systems. So they have stated that they have used the intelligence domain and claims that their NMT scores a blue points of 44, and the SMT system claims to have a score of 25.03. So obviously it is showing that NMT is showing a better blue. So here I want to state one thing is that even though there are multiple works that has been done, okay, so some works haven't specified in which domain they have worked, some works haven't stated how much of amount of data they have used. So we cannot compare their blue scores, which of these systems will be better. Now with our system, so corpus preparation and pre-processing. So we have used the data from tourism domain available from TDIL in open domain. Along with that, we have also developed some newly developed corpus belonging to entertainment, tourism, and agriculture for our training program. So pre-processing of this data involves tokenizing, true casing, and cleaning. So the English side, the English language side pre-processing, we have used inbuilt tools of Moses and open source SMT toolkit available, while the pre-processing of Manipuri sentence is not supported by Moses. Therefore, we have handled it separately by using the Indic NLP tokenizer. And for this language, Manipuri, there is no true casing required. So true casing has been picked and cleaning is done by processing both the English side and Manipuri side at once. Here I'm showing you the corpus distribution of training hour system. In agriculture, we have used a parallel sentence of 10,000 sentences and language model 500 sentences. In entertainment, again 10,000, the same language model distribution. In tourism, we have used 25,000 sentences, parallel sentences, and a language model is trained using 1000 sentences. So this is the architecture for a SMT system. So we have a parallel corpora of English to Manipuri, from which we train the translation model, and we train a language model by using only the target language side corpora, the monolingual corpora of the target language side, that is Manipuri out here. So we train a language model out here. So by using this translation model and the language model, we make use of a decoder which finds the maximum probability, which finds the maximum the sentence having the maximum probability, which selects it and gives the output. The detailed explanation is given out here. In SMT, a source language sequence, examples denoted by E, is translated into a target language sequence M by computing the most likely translation using the following equation. Probability of E and M is given by the argmax function, the maximum, it is a maximizing function, which computes the probability of M given E. By using Bayes rule, it is further reformulated as in equation number 2. So in equation number 2, the component P of M represents the language model, and P of E given M is the translation model. Now, language model. So to train a language model, only the monolingual target language side is used. So here we have used a 3-gram modeling technique to compute the probability of the Manipuri sentences denoted by P of M. So the component P of M is calculated by using the Markov-Chain rules as specified in equation number 3. So what is the purpose of language model? The language model makes the translation system aware of how the target language should appear and ensures fluent output. Translation model. The translation model computes the probability of a source sentence for a given target sentence and tries to find the best translation of a given phrase. The probability E of M is I'm not saying this. Sorry, is computed as the summation of all probabilities with possible alignments A between the phrases of English and Manipuri language. Here I have mentioned earlier, I am using the phrase-based SMT. So instead of aligning by word, we are aligning by phrases. So that's why I have specified with possible alignment A between the phrases of English and that of Manipuri. So the role of translation model is to ensure that the source sentence and the target language are good translations of one another. Next, we have decoder. So the decoder takes an input sentence in the source language format and uses the translation model and the language model to translate them in the target language, that is Manipuri. The decoder is responsible for determining the best translation out of all the possible candidate translations, for which it uses the argmax function specified in equation number 1 and 2, so as to find the maximum translation probability of all candidate translations. Now, evaluating with a system, we have used the automatic evaluation view, that is bilingual evaluation under study metric, which is the most dominant and language independent metric for measuring translation quality. Table 2 below shows the blue scores of each of the systems. For agriculture and entertainment, we have used the same training data size, okay, and we have tested over the same test data size, for which we have achieved a blue score of 7.03 and 6.52. Here I am going to state that even though we have used the same training amount and same test data, the blue score varies. This suggests that the blue depends upon the test data that we are using. So for our system, our test data is totally different from the training data. So with the use of test data, the blue score comes different. So one thing I want to point out is that it will not be wise to compare the blue results of one paper with those of another paper, because we never know in which domain they are testing the system and which test case they are using. Another, we have tourism domain, which was trained on 25,000 sentences, and we see that there is an increase in the blue score as compared to agriculture and entertainment with a much lesser training data sizes. So in table 2, we observe that blue increases with increases in the training data. The increase in the training data in tourism domain provides a significant increase in the blue score. Therefore, amount of training data directly affects the quality of a system. So the size and the quality of a training data is a very important factor in determining the quality of a system, of an SMT system. For entertainment and agriculture domain, though we have used the same data set size for training, there is a variance in the BLEU score. This suggests BLEU depends on a test data selection. As such, BLEU from different systems are not comparable even for the same language pair. Our analysis showed that the quality of SMT systems can be improved with increase in quality and quantity of the training data. So in conclusion, with our we have read the systems of different domains based on BLEU metric only to see the result with a little amount of training data at hand. The dataset used here is insignificant for the well-functioning of a system. However, our work provides an insight on the practicality of the system of the SMT technique for English to Manipuri translations. Our analysis, we get to see that even for a small amount of training data, the SMT performs a good output measured by BLEU. Our work is an exploratory work to analyze the potential and suitability of the phrase-based SMT. Our further work will be exploring both SMT and NMT technique to further refine the outputs. So with this, I come to the conclusion of my PowerPoint. And these are some of the references that I've used for my paper.